Antarctica. It's the coldest, driest, and windiest continent on Earth. Technically, it's even a desert. Some parts of its interior receive less precipitation than the Sahara Desert. Winds here can rage at over 200 kilometers per hour, and winter brings months of absolute darkness. Despite being almost entirely uninhabitable, Antarctica is far from empty. More than 30 countries operate over 70 research stations across the continent, with around 5,000 people living there in summer, and about 1,000 enduring the long, dark winter. Some of these research outposts stay open all year. Others operate only during the slightly less brutal summer months. But together, they form the foundation of global science at the bottom of the world. Each station has its own scientific focus. Some drill deep into ancient ice to uncover clues about Earth's climate history. Others study rising sea levels, track solar storms, or gaze at stars from some of the clearest skies on the planet. But these outposts aren't just scientific marvels. They're engineering feats. Built in the harshest conditions on Earth, they have to survive isolation, freezing temperatures, and months without sunlight. In this video, we'll explore not just what these stations do, but how they were built, how they function, and what it truly takes to operate in the last great wilderness on Earth. Because in Antarctica, when something breaks, there's no help coming. Constructing anything in Antarctica is like assembling IKEA furniture during a never-ending blizzard. Except if you forget a single bolt, you might have to wait an entire year for the next shipment. There are no roads, no supply chains, and no room for error. Everything must be shipped in by air or by sea during a narrow summer window. Cargo planes like the LC-130, Hercules, fitted with retractable skis, land on blue ice runways, while massive supply ships have only a few weeks to reach coastal stations before the sea freezes shut. Most buildings arrive as pre-made modular structures, flat-packed, tested, and designed to be quickly reassembled by small crews working against the clock. Work crews sleep in insulated containers, wear heated suits, and use specialized tools that won't crack in the cold. Temperatures can plummet below -50 degrees Celsius, and high winds can bring operations to a standstill in minutes. A single delay can leave millions of dollars of equipment frozen until the following year. And yet, despite the odds, countries have not just survived here, they've flourished. At the core of American Antarctic efforts lies McMurdo Station, a frozen city built on volcanic rock at the edge of Ross Island. In summer, McMurdo transforms into the largest community on the continent, with over 1,000 scientists and support staff. It's not just a base, it's a fully operational town, with laboratories, dormitories, workshops, a power plant, and even a coffee shop. McMurdo acts as the logistical heart of the entire U.S. Antarctic program. Supplies arrive by ship or aircraft and are distributed inland by ski-equipped planes or tractor convoys traveling along the South Pole Traverse, a snow highway stretching nearly 1,000 miles. In 2019, the U.S. launched the Antarctic Infrastructure Modernization for Science, AIMS project, a $300 million initiative to replace over 100 aging buildings with just 6 ultra-efficient structures. These are prefabricated, container-shipped, and built to minimize environmental impact. They include triple-pane windows, high-grade insulation, and smart energy systems. Community areas like lounges and wellness centers help scientists cope with the long polar nights. McMurdo is being reshaped into one of the most advanced and sustainable science hubs on the continent. Further inland, at the exact South Pole, lies Amundsen Scott Station, perched atop 2,850 meters of glacial ice. Completed in 2010, this sleek, elevated structure is built on hydraulic jacks to stay above the accumulating snow. Its diesel generators recycle waste heat to melt snow for drinking water, and in summer, solar panels provide about 14% of its energy. Inside, a NASA-designed greenhouse grows fresh vegetables, while outside, powerful telescopes peer into deep space, studying the cosmic microwave background from one of Earth's darkest skies. Now imagine something even colder. Welcome to Vostok Station, the coldest place on Earth, where the temperature once hit a bone-shattering minus 89.2 degrees Celsius. Perched nearly 3,500 meters above sea level, the air here contains just 60% of the oxygen found at sea level. The closest coastal base, Progress Station, is over 1,400 kilometers away. Resupplying Vostok requires massive convoys of tracked vehicles, making their way across vast stretches of ice under extreme conditions. In 2024, Russia unveiled a brand new wintering complex at Vostok. 5 interconnected modules elevated on steel pylons to avoid being buried in snow. Each module was pre-built in Russia and shipped across Antarctica in pieces, a logistical marathon that spanned several seasons. Inside, walls are insulated with 80 centimeters of thermal padding, and heat from diesel generators is recycled to warm the living quarters. Solar panels help out during the short polar summer. This base now supports 35 people in summer and 15 in winter, and even includes a sauna, gym, and cinema room, vital for mental health in such isolation. But Vostok isn't just about survival. It sits atop Lake Vostok, a subglacial lake buried under 4 kilometers of ice. Research here could reveal ancient climate records and possibly microbial life in conditions similar to the icy moons of Jupiter and Saturn. In contrast to Russia's endurance model, China is building for expansion. Over the last 4 decades, China has established 5 major Antarctic research stations. Each plays a role in a broader logistical chain, stretching from the coast to some of the highest, coldest points on the continent. The newest addition is Qinling Station, opened in 2024 on Inexpressible Island near the Ross Sea. Designed in the shape of the Southern Cross constellation, this base uses solar, wind, and hydrogen energy for over 60% of its needs. With capacity for 80 researchers in summer and 30 in winter, it's one of the greenest and most modern on the continent. China's first base, Great Wall Station, built in 1985, operates year-round on solid rock in West Antarctica. It's added hydroponic systems to grow fresh food. Zhongshan Station, established in 1989, serves as a key logistics hub, supporting up to 120 people and leading polar atmospheric research. Inland lies Taishan Station, a smaller summer-only base supporting glaciology research. At the highest point on the Antarctic plateau sits Kunlun Station, open only in summer but critical to deep ice core drilling and astronomy projects. By 2025, it will host the Kunlun Dark Universe Survey Telescope, aiming to explore the cosmos from one of the darkest, driest places on Earth. China supports all this with 2 powerful icebreakers, Shuilong and Shuilong 2, ensuring supplies keep flowing year-round. The UK's Antarctic approach is defined by flexibility and engineering innovation. At Rothera Station, their primary base on Adelaide Island, the UK is building the Discovery Building, a 4,500 square meter, ultra-sustainable facility designed to consolidate infrastructure. Built in the UK and assembled in Antarctica, it includes triple-glazed windows, solar panels, and smart systems that reduce emissions by 25%. Bright, open workspaces and green zones help boost morale during long winter nights. Even more impressive is Halley VI, the world's first relocatable station. Perched on hydraulic legs with skis, it can be towed across the ice when conditions become dangerous, which is exactly what happened in 2017 when a giant ice crack threatened the base. Halley VI was moved 23 kilometers inland, one module at a time. Despite its remote location, it includes not just labs, but a climbing wall, library, and even a pool table. It's here that scientists first discovered the ozone hole in 1985, and today it continues leading atmospheric and space weather research. Finally, we arrive at Concordia Station, one of the most remote and extreme outposts on Earth. A joint project between France and Italy, Concordia is perched over 3,200 meters above sea level on Dome C, surrounded by a thick blanket of ancient ice. Temperatures can drop below -80 degrees Celsius. For 9 months of the year, the station is completely isolated. No flights, no resupplies, no visitors, just the crew, alone on a frozen planet. Because of these conditions, Concordia has become a testing ground for future Mars missions. Researchers study not just the atmosphere and glacial records, but also the physical and psychological effects of long-term isolation. It's one of the only places on Earth where scientists are essentially simulating life on another world. From floating labs to permanent cities, from sled-mounted modules to solar-powered outposts, Antarctica is a living laboratory of science, survival, and ingenuity. In the coldest, harshest place on Earth, humanity is pushing boundaries, not just to understand our planet, but to prepare for challenges that lie far beyond it. These stations are more than buildings, they are frontiers, and the story of Antarctica is only just beginning.